I think Alex has done a nice job of setting this up, and I just wanted to say that what I'm talking about is definitely from the point of view of kind of the edge or the outside in, or establishing trust for, I guess, what we could loosely call a distributed application, and then moving, there are things we could think about federating that trust and so on, but that's not where this is at this moment. But this is still something that can be used to solve problems, and I think that's what's been important to me in this process. And I think some of these questions that have shown up on Slack are, kind of interesting, but I would leave them to other people to maybe try to understand whether there are good ways to move forward in that area. So this is just sort of a rough outline of what I'm going to say, but we are going to take a break in here. First, I'm going to kind of overview the use of the Versec language and the trust schema enabled application transports that we've, kind of lock in with that. And you put these together to get a trust zone. And we have tools and libraries and examples at this repo. DCT is Data-Centric Toolkit, and we're adding things to it from time to time. And then what I'm going to do is illustrate this by developing an example trust schema that I'm calling Office, because it's for a simple office. And then we'll talk some more about how we use Schema Compile, which takes a trust schema and compiles it, and it's going to check for the consistency and the correctness in the trust schema. And then that will lead us to, well, how do we create identity bundles, and what are they in this context? And a little bit about how, once we have all this, the distributors, which are part of the toolkits library, how those things enable the trust zones at runtime for the application. And I'll say a few words about how to run the example and future work. But so the big thing is, why do this? What do we gain from this approach? Can I have the next slide, maybe? So this trust schema-based transport is enabling the concept of a trust zone. And to try to illustrate what that's like, I've kind of come up with this example of, a bunch of people at a Wi-Fi cafe or something. And what we're doing is we take the security roles and the certificate specifications for this particular distributed application, or that we want to create a trust zone for, and they're turned into a trust schema, and that gets bundled with a particular trust anchor and a unique signing chain identity for each participant, each entity, which an application's DCT-based transport could use in order to join the trust zone. So here I'm showing the trust zone in green. And the idea here is that Alice takes her device, which has already been configured with an identity bundle, into a Wi-Fi cafe. And her DCT-based app is going to automatically present her credentials, that is her signing identity and the whole chain. And then it's going to learn about all the other members of the trust zone. And the way it does this is these three little boxes inside are different collections. And the DCT app will automatically set things up to have the certs, that's where the signing identities go, and the publications, that's the information that the application is exchanging, not this sort of side information of certs, and also a key collection if you're encrypting for privacy. So this all happens without the app really having to know, as long as it's using a DCT-enabled transport, which is using a trust schema. So outsiders, these are these two black laptops, they can't get their messages past the initial validation of packets. They're going to be discarded early because they don't have the right signing identities. And if we are using privacy, those outsiders can't even snoop the pubs because they're going to be encrypted. But I will note that the public cert chains are not encrypted, and the symmetric keys are encrypted by inside of them. The symmetric key is encrypted with the public key of each of the validated trust zone members. So it's it's present multiple times, but we do use a fairly reasonable key hygiene there. The other notion here is that a particular identity bundle is needed to join a particular trust zone. So I've kind of illustrated that over here with this picture where we have the black hat guys decided, well, we're just going to make our own zone. So they have DCT app 2, and here's their zone, and they can happily go ahead and communicate because they have identities inside of it. But we can have one person who has an identity in both zones, and they can go ahead and have apps that are communicating with each zone. So hopefully you trust that person not to pass the information between the two zones, but so be careful who you give identities out to. Well, what's in the identity bundle? And it's got 3 main parts. It has the root of trust, or the trust anchor, and that's always in the form of a self-signed certificate. And then there's a trust schema for the zone, and that's in certificate form, and it's signed by a chain that ends at the trust anchor. And then there's a unique signing identity. So each bundle has a unique signing identity. The first 2 are going to be the same for everybody in the trust zone. And then and those things all have a private key and a public cert pair for the signing part. And then they're going to have their whole signing chain that terminates at the trust anchor. And it has to conform to trust anchor rules. That is, the identity will conform to trust anchor rules, because that's how everyone else can check and see if that cert is something that they should go ahead and add to their collection of certs that they trust, the collection that they have on their computer, for not the collection that's out in the cloud. So, well, it can't get out there if you don't trust it. So multiple trust zones are existing here, and they're completely independent, but they're on the same network, right? And you could use this in a very simple fashion where what you're really just giving out is a signing identity. But as we go forward, I'm going to show you, I'm more focused on ideas of finer grained security where we're enforcing roles that people have. But you don't have to do that. I mean, you could just completely set up a trust zone based on having a signing identity. And if you have a signing identity, you can send anything within that zone. I guess I've already noted that a user with 2 different identities can join 2 different zones. And this notion, we could think of ways of doing federated sharing between the trust zones. And that's something that is more on our radar for the future. I think there's ideas in that area maybe that Alicia is thinking about, and I don't know if she's going to have any words about that or not. But I think there are lots of different ways that one could approach that. And that's sort of reflecting the idea that the way that I'm thinking about this architecturally is more building up from the trust zone upward. And I know this is kind of different from the way that some other things have been done in ICN, which is more focused on kind of replacing the internet. And I've been a little bit more focused on how can we solve some problems that exist, at the edge or in areas of more operational technology than replacing the internet. But I don't think that they're mutually exclusive, but I'm going to let people like Leisha worry about that. So this is the example we're going to work on going forward. And in this example, I'm going to go over the idea of having a small office that has some people in it, and we're going to put some restrictions on them. What I've got is a small office. Of course, this is slightly hokey, as all examples are, but I hope it has a bit of reality. So we've got 4 people who use their phone apps for access. So let's assume that they're using their phones kind of like smart badges. And we've got Bob, Alice, Herb, and Emily. And Alice is going to be a manager. So we've got 6 rooms here. Room 1, 2, 3, 4. The hall is considered a room, and the conference room is a room. And each room has a a room controller and think of it as a Raspberry Pi-like thing in each room that is controlling the door lock set, a light, the temperature, the screen. And in the hall, it only has a light and a door lock set. And I'm just sort of assuming these are kind of directly connected things, you know, they've got a wire or something or some other technology. And then we want to have some rules on this. And I've got some simple rules. So if you're an employee, you can control all the functions in your assigned office. If you're a manager, you also get to control the conference room in the hall. And the guard has this, the idea here is that the guard can control all the locks and the lights and the temperature as a group, but not one by one. So it's sort of the idea of you know, he unlocks all the doors, turns on all the lights, looks around, doesn't see anything, you know, undoes all that and leaves. And the room controllers are going to publish the status of their functions after every time they get a command. Like if it says unlock door, they're going to say doors unlocked is the status. If we start from those, we can sort of think more about the rules. Can we go to the next slide? About the rules for the office, and I've kind of written them separately here. So if we were going to write them down, we'd say, okay, here are the roles that we have. We have an employee role, we have a manager role, we have a guard role, and we have a room controller role. Then we have the functions that the room controller controls: light, screen, temperature, door. And then we think about what is it that we need to communicate about. And we want to communicate commands that say, you know, unlock the door, turn on the light. And the issuer of a command has to be an employee, a manager, or a guard. A room controller can't issue a command. And the commands would go to each function. So it could be like on, off, unlock, lock, you know. And I just sort of said for temperature, the idea that you have an out of office, you know, energy saving mode and a heat mode and a cool mode, so that there's some pre-planned temperature that you can set it to. And then the idea of communicating about your status. And in that case, for now, you have to be a controller, and the status is the status of a function. And then this notion of a location, which could be which room or whose phone, or we have maybe this idea of all that we need for the guard, right? If we want to talk to everyone. Here, I'm going to take those rules that are written in English, and I'm going to show you how we turn it into a text file in Versec. And this is sort of the overview. Let's go to the next slide, because I'm going to highlight these. Okay, so we're going to take this top thing where we've got these are all rules about the room controller, right? So we're going to come over here and write these. And probably before I do this, I should note, we have one form of publication here. See the hashtag pub, and that's the form that we're going to use for everything. So starting from that, we're going to derive one for the room controller. And it's going to say, well, I derive from the pub, and I have these further limits. I've got the function, if the function's light, or if the function is screen, then I can have arguments of on or off. If the function is a door, I can have arguments of lock or unlock. And if the function is temperature, I can have arguments of out of office, heat, or cool. So when we write it this way, it's kind of a lot like our words that are over on the left-hand side, right? And that's the idea here. And then the next part of this is we say, well, we want to say status, which is derived from a controller pub, and we're setting that topic to be status, and the location has to come from this room ID that's going to be found within your signing chain, and you're signed by a controller cert. So that's expressing our rules. I guess what I'm going to do is go through. I wonder if I should see if there are any clarification questions, or should we slip on to the next one and then ask at the end, or is this kind of making sense how we go from English to the trust schema? Okay.
The only thing I would ask is status is you basically declare a new variable that will be used later?
No, status is another form of publication. That's another specific publication. So a status publication takes everything in the controller and further restricts the topic to be status and the location to being the room ID that's in your signing chain.
Oh,
And it has to be signed by a controller, sir.
And maybe a stupid question, it doesn't have to start with this hash?
No, the hash is for the fundamental definition, and these are all basically derived from that publication. So there's only one. These are forms of pub, I guess. So if it has a hash, it's like a new form, a new publication. But if it's derived from it, it's going to have this type of format where it will say, okay, a controller is a pub and these further restrictions. And then we have that status is a controller and. So now is that making more sense? Okay, yeah. Let's go to the next slide. So now let's look at the next group of rules, which is that an employee or manager that can publish commands to their assigned room controller. Okay, so we're still going to use that nice controller thing that we have up here, but we're going to say, in this case, the command that we want to, what we want to derive from the special type of publication is a room command. And it takes that controller, all the restrictions that are for the controller, and it adds that the topic has to be set to command, and the location comes from the room ID in your signing cert, and it has to be signed by either an employee cert or a manager cert. So we've also said that the manager can publish commands to the conference room and the hall controllers. So what we do here is we're going to use our handy controller version of the pub version, and then we're going to say, okay, a manager command is that controller, all those specifications, and we're saying that the topic must be command, and the location can be conference room or hall, and it must be signed by a manager cert. Okay, so here's the guard who can only publish commands in unison. So let's kind of take a look at what's going on with the guard. So the guard doesn't derive from controller. It comes from that publication, that basic publication form. And it's going to say, well, the topic, if it's command, that's one version. When we use location all, and then another version is, or along with that, we can say we're limiting function to light and the things that the arguments you can give to the light, or we can do a lock with its arguments, or we can do temperature, and the only thing we can tell temperature is out of office, because the guard's just kind of setting everything down in case somebody forgot to. So that's what's going on here. So are there any questions about that?
Can I ask I can't type fast enough to ask questions in the Slack. Okay. It seems like what you're doing here is sort of defining abstractions for these different types of objects, except only sort of. And I think you might actually benefit from actually taking a lesson from programming languages more generally and define real abstractions. So for example, lights can go on and off and screens can go off and on and off. They're actually very different kinds of things, because on a screen, I can stream something to it. I might actually want some kind of a policy that says you can only stream certain kinds of streams to it, for example. I can't stream to lights. So they're just very different abstractions.
Oh, sure. I mean, I've simplified this. If you wanted to do that, you would write more. There's nothing that keeps you from writing different rules, or writing more things for the screen, right? The screen could have a lot of different types of functions. That the whole reason I did it this way is to be simple, right? But we've done other things, you know, try this at home, right? We've done other things that have more fine-grainedness or more levels of control or more differences between things. But this is just meant to be simple and illustrative. There's nothing here that prevents you from making the commands to the screen different, right? We could say, oh, okay, we want to have a different set of, we want to have a longer set of arguments or different kinds of things that can happen with a screen. This is just an illustrative example.
Okay.
Okay. So yeah, I think if I put a lot of stuff in,
but it does seem like you're defining a programming language, and
yeah,
you know, using that terminology you might gain from that, is all I'm saying. There's been so much work done on abstractions and languages.
Yeah, I guess some of the stuff in there's a little document on this on GitHub that, and I think in some of that, I think that's discussed a little bit more as a language, but I guess I'm trying to talk about having it in use, but yeah, I know that Van has written some stuff up about it as a language, and maybe at some point you could get him to talk about that, but he can't talk right now, so okay.
I can ask one more question. This one specific to the first restrictions of this guard command that specifying that location is all.
Mm-hmm.
So does it mean it literally have to be all in the interest, or is it somehow is it a wild card-ish thing? That can be...
Well, it's not really a wild card, right? It will say all. So like I will show a little bit of what the application looks like later. You have to subscribe to all in order to, you know, in order to get things that are in that topic. So room controllers, the idea is that they're both going to listen to things that are for their location, and they're also going to listen to things that go to all. And you can use that type of idea, by the way, to set lots of, I don't know, like aliases, right? Like if I'm a light in the living room, I can listen for things that are sent to living room, in case somebody wants to turn all the lights on or off at once. So there are some examples like that, I think, in the example that's up in the repo now. But, you know, I think it's just, these are things that we've been doing this by doing examples, and kind of, you know, you kind of have to try things out. And that's also been evolving the language as I try to do different applications. Then I usually, Van adds new features to the language to make it easier for me to write the trust rules. And I think we would be responsive to input, but the input needs to be somebody's really trying to do stuff, not, you know, like, gee, wouldn't it be nice if you did X? I just have to say up front that we won't respond to that type of input. It's more like, I'm trying to solve this problem and I can't do this. But that's just our bias. Okay, next slide. All right, what I wanted to talk about here is the publication and cert relationships. And I think you already got a flavor of this. But for this particular setup, we have one publication and everything goes down from there. Let's go to the next slide because, oh, wait, before you go, I just want to, can we go back? I'm sorry. This was made by using the graph viz commands, and you can use it on output that comes from the compiler. The first part of the output is actually in a format that tool can read. So you can make these things automatically from your trust schemas if you wish. Okay, next one. Okay, so here's what's going on here. The pubs, remember we had some discussion with Alex about the different types of pubs, and this is kind of showing you that these are the different types of pubs, and you can see over here highlighted, right? This corresponds to what's going on here. So we have 4 different types of pubs. Okay, let's go to the next slide. Okay, so this is showing you that relationship that is signed by relationship. So each of these pubs has somewhat different signing relationships. The status has to be signed by a controller cert, and a room command has to be signed by either an employee cert or a manager cert. And a manager command has to be signed by a manager cert, and a guard command has to be signed by a guard cert. So that's, what's going on in that part of the trust schema. Can we go on to the next part? Okay, so now this part is telling us that all of these certs in their cert chain have to be signed by a room cert. It's just the next thing in the chain. And you can look and see what a room cert is just below the box there. And the room cert will have a room ID in it. And remember that we are actually pulling that room ID out and using it within the runtime library. So it kind of means you can't use anything but something that's in your cert. Okay, shall we move on to the next slide? Oops. I guess, can we go back to the previous one? Then I do want to say something else, I guess I forgot, which is that what I've got here is the room cert is signed by a config cert, and that's signed by a net cert. And the length of a chain here for configuration would kind of depend on your application. But, you probably don't want to be using your trust root directly all the time. So the configuration cert is in there to kind of be something that helps you protect your net cert. And you might have multiple configurers. And if they have an identity, you also have a way to trace any configuration back to a particular configurer. So just the notion here is that you can make this chain as deep as it needs to be for your particular application. Okay, let's go ahead and move on. Sorry, I just felt like I should say that. And this is just a little bit more focused on the bottom part of the trust schema and how those roles are translated to the cert chains. And I want to make it clear that a lot of these details about the certs and how they get combined, they really are critical to what we're doing here. But there's a lot of discussion about it in the conference paper that I've got at this conference. So I just, take a look at that if this is the sort of topic that interests you. So I'm going to start at the first box here, that certificates in that signing chain are always going to have a role. And we're going to, when you do the configuration, you're going to get something that has both a role and an ID within that role. And the ID is really particular to what you want it to be. I mean, it could be a name like, Alice or Bob. It can be room 2 or room 4 or conference room, or it could just be a number like 42. And next we see we've got these certificates that are in the signing chain that are used to assign those rooms by identifier, right? So that's why we've got a room cert in the signing chain. That's why the employee cert is signed by a room cert. The room cert that signs guard is, it's just to kind of simplify things. You could imagine, and maybe that would be an exercise you'd want to try if you're playing around with rewriting trust schemas. You could imagine not having the guard signed by a room cert and changing that particular signing chain because the all doesn't, he's constrained to saying all in any case. So the configure certificate in the chain, I've already mentioned that it kind of protects the trust schema usage. And here we've got our single root of trust. And that's one, if you screw this up when you're writing the trust schema and you go to compile it, which I have done, that's one of the error messages you'll get out if you have multiple roots of trust. And that usually just means that you forgot to put one of the the is signed by relationships in. And all of our publications for this particular trust schema are going to use EDDSA signing, and that includes the self-signed trust schema cert. And then finally, in this case, we're going to use encryption of the on the wire or the sync data packets in order to preserve privacy. But we don't have to do that. We could use EDDSA signing here. But if we do this, we sort of automatically generate symmetric keys. And the symmetric key process is about, takes about half the time as the EDDSA process, at least that we've measured so far, but we should try it on some other platforms. Okay, I guess let's try the next slide. So these are some things I want to say about Schema Compiler, which is the compiler for it's the compiler that you run the trust schema through. And what it does is it uses the rules in order to ensure that all the constraints are consistent. And I'd already mentioned it makes sure that you don't have multiple roots of trust, but it also makes sure there's no contradictions in your rules and your signing chains. And then the compiler also makes sure that the publications that are produced by the constraints are grounded. And that means that every field, every tag can be filled in with either a literal string, a component in the signing chain, or a parameter that has to be filled in by the application. And this was already mentioned earlier. So the compiler is going to construct templates which are used by the runtime builder and validator. And then those signing rules must form a DAG with a single root of trust. And you've already seen that too. So I wanted to note that in the DCT repo, there's a tools subdirectory, and it has a lot of utilities that you can use to look at different elements of the schema. And there's a lot of detail for people who might be interested. So here's an example of builder dump, and that'll just show you all the pubs that a particular identity can produce. So this is dumping out the bundle for the conference room. So remember that the bundle has the trust anchor, the trust schema, and the identity for that particular, in this case, an identity for a conference room. So it's coming out and saying, well, these are the things, these are the publications that the conference room can produce, the conference room controller. And it can produce ones that are about temperature, about light, about screen, and it can be, off, on, lock, unlock. These other things are tag identifiers, and let's not go into that right now, but you get the general idea, hopefully. Okay, let's go on to the next slide. And so we want to go from trust rules to an identity bundle. So I've already talked about what goes into an identity bundle, but I want to talk about how we get there. And these, the bullet items over here on the left-hand side are sort of a review of things that I've said so far, that we're using Versec's declarative language to express our trust rules, and what we think of is kind of a readable fashion. I hope you agree when you've seen how they relate. And we also use a compiler that can check those rules. And then once we have a good trust schema, the application's transport is going to use a verifiable, and that's by signing, compact version of the trust schema in order to construct, sign, and validate communications. Then a trust schema and its trust root in cert form, both in cert form, are distributed with that signing identity in an identity bundle, and they're used by the application to join a trust zone. So everybody that has that same trust root, that same trust schema, and an identity bundle, an identity that's legal under that trust schema is able to join that trust zone. And the signing identities consist of a private signing key with its associated public cert and the entire signing chain of public certs. And again, they have to be specified by the trust schema. So keep in mind that only the signing key needs to be kept private. So out of all the different elements that are in that bundle, that's the only thing that you want to make sure that you're not exposing. And these items are sufficient to join the trust zone. And the DCT transport, the things that are in the library, is going to handle the finding others. It's going to validating and importing all the other certs that are out there. Let me go to the right-hand side, but before I do that, maybe I should see if there's any questions about, about kind of the things that I was summarizing before I start talking a little bit more the nuts and bolts. Okay.
Have a quick clarification question. So for the manager can control many rooms. So its certificate, I suppose, can be signed by many different room certificates. Is that right?
Well, that's not the way that it's done in this case, right? In this case, the manager is controlling their own office room, their own assigned room, plus the hall and the conference room. And that manager certificate gives them the right to publish commands that will have those other locations in it. So essentially what it does is that manager certificate in itself allows it to publish commands to the conference room and the hall, in addition to its own room.
Okay. At the same, this can be applied, the guard, then we can say the guard can control many rooms. Is that right?
That's right. But the guard can only control them all in unison in a way that's kind of, and also the guard can only turn the temperature to out of office. I just kind of have a model here of a guard that walks in at the end of the day, or sometime during the night, and all the lights go on, look in all the rooms, make sure everything seems reasonable. And if any of the thermostats are on, you kind of turn it off, and then you leave and lock everything and turn all the lights out, which also means if somebody left their light on, it gets turned out. So that's the model there, but the guard does have this ability to talk to everything, but then we limit the guard to not being able to control screens and not being able to turn temperatures, basically not being able to turn heat and cooling on.
My basic question is, there can be many chains, right, from a particular cert to the root. So there can be many identity bundles for the same certificate, depending on what you're trying to publish, right? So when you publish something, you have to pick the right identity bundle for that particular data.
That is a great observation, and that's exactly what the model is, but only part of the finished library enables you to do that right now. So that's something, we were just talking about that recently, but it's a little bit over to the side, which we haven't needed it yet. So there's some other things that we want to get done first. But yeah, that's the idea, is that you could have, just as you can have some keys on your keychain, you could have different identities. And yes, in the signing, you'll pick the identity, you'll pick the one that is the least privileged, and you'll use that.
Okay, thank you. Karen, you can go ahead.
So my question is the other side of that, which is, imagine that in many offices you have a whole guard office, and they're sort of interchangeable, and on any particular day each guard is assigned to some location to sit and be there, but tomorrow it may be somebody different, or at lunchtime it may be somebody different. So you've got what you may want instead is something that's attribute or role based, rather than individual based. It's not that, you know, guard A is the guard for these 4 offices. It happens to be any of the guards who's, you know, authorized for today.
So that's a possibility. I'm thinking, though, you know, there's more about this in the paper, that these certificates don't last forever. So maybe, you know, maybe Frank gets a certificate for that day, and you still kind of, it's still kind of good to have an identifier, because if you've saved all the commands that are issued and somebody did something they shouldn't, right? Like Frank walked in, turned all the lights on and didn't leave for 2 more hours or something, you can find out whose certificate did it. You know, this is just sort of a made up example, but, you know, I'm just thinking about ways that you can use this, but I'm sure you could do something, yeah, in a different approach, you know, kind of like what you're saying. I think that has more to do with how you decide to give out and configure the certificates. And, you know, these are all sort of like rich areas for future research. You know, this is the scaffolding, and, you know, a lot larger skyscrapers could be built, but I haven't done that yet. And some of these things I won't ever do, but I would certainly encourage somebody else to do it.
And if I chip in a word, I think that the details can change. Like Lam pointed out, you need a different search for different roles, different publications. I think if I step up 2 levels and make a quick summary, it's really that we need to change the way of thinking. Anything can last for 3 years or 3 months. This really get into the direction of doing fine granularity security control. Exactly how fine is fine, whether it's attribute based or something else based. I think that's like a Kathy said. That's really need lots more effort from lots more people to look into this.
Well said, Leisha. Okay, should I get back to our small world here after all those big world concepts? So here's what you can do for a small example like this. Let's look on the right-hand side, and we're going to go from those rules, you know, think back to where we started from, and we said, oh, we've got an office, we wrote down the rules. Okay, now we figured out how to get it into a trust schema, and trust me that trust schema compiles. Although I will say that, just a little aside here, that exact version may not compile with the schema compile that's out right now, but we're going to push some more stuff out in the next few days to a week, and then it will definitely work. This will push out the version that I'm using here at home. So you write your trust rules in that Versec language. You have a text file, and then you're going to use Schema Compile to test it for soundness. And and the way you do it, I've written over here to the right of that, the command line command that you would use. And that's just telling you that the output should go into office.scm. And that is going to be a compact binary trust schema version. And you can see that I screwed up here and have the wrong, I have ex.scm here, but I'm sure you're all smart people and can figure out what's going on there. And I'm getting a junk call. Hang on. Go away. Okay, so out of Schema Compile comes all these lovely diagnostics, as well as that compact binary trust schema. And now the next step is you are going to make your root of trust. And there's a nice utility included called makecert. And we're saying this is the signing that we're using, EDDSA. And we're saying we want to call this thing office.cert. And office is the name of our trust root. Okay, now we've got it. And the next thing we want to do is we want to use it to sign the trust schema. So this is the command line command that you'd use to do that. You say make a schema cert. You say put the output into office.schema and use office.schema SCM as the binary and sign it with office.root. And the next thing you want to do is make a signing identity. And here, of course, in identities, that format, comes from the trust schema rules. And when you're validating, it must match them. And here I just put something in which, again, I put a role of student, which was left over from a different example. So let's think about that as saying manager. And so it's signed with EDDSA. What we're going to do for the output is to go into alice.cert. This is going to be the name, and which would include a role. And then finally, it gets signed by office.root. Okay, now we want to make an identity bundle for Alice. And there's also a handy utility for make bundle. And again, the output file is alice.bundle. And these things have to go in the correct order. The first thing is the root of trust. The second thing is the schema and certificate form. And the last thing is Alice's cert. And that little plus sign says that it should include the private signing key, not just the public cert. So if we were going to use that bundle and the command line for some app, we'd say app with Alice.bundle, and it's going to take that bundle and pass it through to the DCT transport, which will do all that communication work for it. So before I go on, are there any questions this far? Let's go to the next slide, which will probably end up generating lots of questions. I need to digress here into things that you need to know about the DCT transport that uses the trust schema, because I'm throwing around terms here, and I already have thrown some terms around, and they're perhaps not clear if you don't know how we're using this. And I should also say, and I think this might be something that Alex and Leisha are thinking about, is that I imagine there are other transports that could use the trust schema, or this is all out in, this is all open source, so you could take pieces of it and put it together in ways to build your own style of transport. But anyway, so here's the idea, is that, again, I wanted to kind of make it clear how I'm designating these different concepts. And the DCT transport is always thinking about publications. And publications are NDN data. But what we're doing at that level is we're thinking about building and validating them according to the trust schema, so we can have some pretty fine-grained security. That's the kind of stuff like, what role are you? What topic are you using? And by restricting all of that, that gives us a fine-grained security. And also we use a signature manager, SIG-MGR, to sign and validate those publications. And that's kind of a newer concept. I mean, it does, signing for an NDN pub, and it does validation, but we needed a place where we could make all these things more visible so we could use them in different ways. So I've developed these signature managers, which are within our library. And, if you are interested, again, look at the code, you can see what's there. And then we have the sync protocol that we use is called SyncPS, and it manages these collections of these publications. And so remember, we talked earlier about the pub collection, which would be the stuff that is directly the application kind of stuff. It comes directly from the messages that the application wants to send. And then there's also a cert collection and a key collection. And those are things that get set up through the transport and the use of the identity bundle. I want to kind of do two things. First, if you look at the picture on the top right-hand side, this is sort of the concept from the point of view of an identity. We're using a shim, if you see that API to the application, that has a pub sub model. It's just very simple, publish a message into some topic and subscribe, handing in a callback for some topic. And the entity itself doesn't have to worry about any of this other stuff. And from its point of view, it's putting messages out into some message space and getting them back. But if we look below that at that picture, those application messages go into a shim, which is the API. And in our example here, we're using message-based pub/sub, which is a fairly general purpose shim. And we're actually in the process of making it slightly more general. And then that kind of makes use of library functions that are in our schema lib. And that's taking care of validating those publications, both cryptographically, which is the signing and validation of the signature, and also structurally, which means the fine-grained part, were you really allowed to say, do you have the right cert to say all those things that you said? Or if you're receiving it, is the cert that signed it have the right to say the things that it said? And these publications get fed into the sync protocol, which manages the topics. But those publications, even though they are NDN packets, they actually get put into sync data. So that's what handles the collections. So the publications don't actually go on the wire or over the air or however you want to think about it. But think about those packets. We already saw in the trust schema that those also have to be signed or they can be encrypted. And if those data, if the sync data fail to validate, if they have illegal signatures or they can't be decrypted, they're instantly discarded. And I want to follow up a little bit. There was a nice question that Dave Aran asked earlier about that, which is, if you don't have the signing chain, you just, for something, if you don't have a validated cert, you just toss it immediately. That's a different model, I know, than a lot of other NDN applications, but we have this model that in order to join the trust zone, you have to publish your credentials first. So in order to communicate, you've got to let everybody know who you are. And I think I'll show that a little bit more in the next slide. And let's see, is there anything important I missed here? But just really that the application just has to focus on what it needs to communicate, and then everything below it is going to take care of the rest. That's the general idea here. And so the next slide, we'll talk a little bit about what that taking care of the rest is, but maybe I should pause for questions about this. And I don't want to go into this in too much detail because anybody who's really interested could go look at the code and the examples that are out there, but I do want to make sure that we're on the same page. So this is that automatically I keep talking about. We have distributors in our library, and we have right now two kinds of distributors. We have one for the signing certs and one for the group key. And what's happening is that they make that connection to the trust zone and privacy just happen automatically. When you want to get started, like the application is creating that MBPS client, and then it tells it, okay, connect, and it gives it a callback, and it says, when I'm connected to the trust zone, let me know, and then I can start communicating. So if you look here, it's, as it says, the app is creating a DCT transport, and it passes in that bundle, like alice.bundle, and that's how all the elements of the transport get started. And if it finds out, oh, I have AEAD signing, so I'm going to need to distribute a group key. And then to join that trust zone, the app calls connect. So let's look at the signing key distributor. The first thing it's going to do is it joins that office/cert collection. And the way it does it is it's publishing out, well, it's going to subscribe to it also, and it publishes Alice's signing cert chain, her whole chain. And then it's going to validate any signing chains that it receives, that it finds out there in that collection, by using the trust schema and the trust anchor. And that step 3 is ongoing. The signing cert distributor is going to keep doing that. So if anybody new joins, it's going to carry that process out, validate it. If it's valid, it will add it to its local collection. So once it's successfully published its signing cert, and this is just a lower layer mechanism, you're just trying to make sure that there's at least one other person out there. And you can do this through looking at, properties of the IBLT and SyncPS. So that's just details. So then you say, well, I need to have data privacy. So now I'm going to kick off a group key distributor. So it goes ahead and tries to join the Office key collection. And if there's nothing there, this particular entity has the ability to be a key creator. It's going to say, okay, I'm going to create a group key. I'm going to encrypt it with the public key of every signing cert that I received over on the left side from the signing cert distributor. And then I'm going to publish that list. Otherwise, if it finds something out there, it's going to get its copy of the group key out of the data, and it's going to decrypt it. And, there's a little bit of mechanism, obviously, that's going on here to try to keep from having different people decide that they're the group key maker. And this could be better, which, I'm happy to let somebody make a pass at doing a better job here, but this works. So after you've done this step, now you've got a group key. And clearly, of course, we redo this periodically. So you've got a group key and you indicate to the app, okay, you're connected, you can start. So you call that, whatever callback was passed into connect. And I wanted to just note here that, which I think I said earlier, and I want to go back to it, that you can create an identity protected trust zone and you can have data privacy without really worrying about the fine-grained trust rules. Like you don't have to, carefully lay out who can say what. An example of this is this mbps0.trust schema that's out in our repo. If you're sort of interested in thinking, well, what if I just want to do this for data privacy? Well, again, you have to have a group though. Okay, let's talk about some notes about running the example. And I have to say that I do not have this example done and out yet, but again, I think I'll get it out within the week. I'm going to try to get it out by the end of the weekend, but certainly within the week. So I'm going to put this example out under examples under Office, and it's going to have the Office.trust and room and phone apps and the MBPS HPP. But because I'm making this more general, I'm going to end up moving this into the library pretty soon. So that might happen at the next push out. And it has, you'll be happy to know, it has this handy script to make some identity bundles so that those steps that I showed you, I guess 3 slides ago, you don't have to do them yourself. You can run this script and it'll do it for you. Unfortunately, if you want to run the examples, you currently have to duplicate the NDN library and forwarder versions that we use, and they are back and have certain patches to them because it's just, we can't keep up with everything. But we're actually working on this and hope to have something that'll make this all easier in the future, but that future is not next week. It might be in a month or two. So, but you could try making changes to Office.trust, and you can try running Schema Compile without running the code, or you could try some stuff like add a status message from the employees to say if they're in office or out of office. So now they can send another type of message, not just a command. Maybe you could add a guest role or a presenter role that is only allowed to control the screen in the conference room. And if you're really adventurous and you're trying to run it, you can run it. And you, from the command line, you could run room, whatever the room.bundle is, and phone with the user.bundle. And keep in mind that you always have to have at least 2 members of a trust zone before anything can happen. To communicate, it takes 2 to communicate. But they can be on the same machine, right? You can set up multiple entities. And also, new entities can join anytime. So I just wanted to show what the code for the room controller looks like so that you can see that the trust schema and use of this structure is meant to make things easier. And what we can do is, if you kind of look down at the main program, you're getting your role back through the shim, which is actually getting it out of the schema lib. So, the shim is kind of hiding all this stuff from you. And you're also getting your role ID that way. And then you can, the very next thing you do is just what I said. You have to connect. You say, I want to connect. And you're going to say which things that you want to subscribe to. And this question, I think, was Karen's about, we are subscribing to both our ID and to all. So we have, but in this case, they're, both things are going to the same place, but you can certainly have different subscriptions, have different callbacks. And what we're doing is this command receive, which is here. This is what gets called back. And all we're doing is if we get a command, we, say, okay, we're, setting that function to this particular argument, and we publish our status back out into the message space. And this is what does that for us. And what we're doing is, since we're an application, we know something about those names that are in the trust schema. Even if, it's possible to have an application writer be different from a trust schema writer. And then what happens is that the application just needs to know, what are the names of these things that I'm communicating about? There has to be agreement between the trust schema and the trust schema writer and the application writer. What are the name of these tags, right? So I was trying to give a little bit of a flavor for that being relatively easy. So if nobody has questions on this specific thing, I'm going to go. So this is what I want to say about commissioning and updating, which I do want to say up front that different ways of doing this is not my thing, but lucky for you, it is Chan Yun's thing, and he's going to talk about this next. And clearly using the bundle on the command line, the way I showed it, is great for development, but not for deployment. But there are a lot of other issues that deployment brings up, and these are talked about in the conference paper at this conference, so you could read that if you're interested. But briefly, I'm sort of expecting the actual app to be managed by a supervisor or some kind of process control program, and that's going to create short-lived signing key pairs that are sort of based on that signing key that you got during the installation process. And so it's not like you have to keep getting a new identity bundle every hour, right? You can create those on yourself and sign them with that signing chain, and then they should validate properly. There are ways in the current best practices to do this commissioning and use TPMs. And what we could do is use that to protect that private signing key, which is the one thing we need to pull out of that bundle and keep private. The rest of the bundle file, it doesn't matter. We can stick it anywhere, someplace where the supervisor knows where to find it and, is able to put that together with the private signing key and give it to the application to start it. And another piece that we don't currently have but would be easy to add would be for the supervisor process when it creates that new key pair to just give the key pair to the application. That shouldn't require restarting. You would need to restart if you had a new trust schema, of course. So I think that you could develop data-centric approaches to doing this, like you might be able to use special collections for some of this, but this isn't something that I've put a lot of thought into. I mean, I think, having an approach is just the way that I've gone now, but fortunately, the world has graduate students who do spend time thinking about these things. So what am I thinking about for the future? So that would be the next slide. And on the planned list that we have are things like some additional features for the Versec language and compiler. And as I said, every time I try something new, Van gives me a new feature. And for the schema lib, maybe some new features to make it easier to express different publication variants, and also this issue that Lan brought up to be able to make use of having multiple signing certs, multiple identities, so to speak, or which key do I use now? I'm working on making MBPS more general. This is pretty short term. I think I might get this out in the next week. We're also working on a DCT NDN face that will make more efficient use of broadcast networks and will help sync PS to be more efficient. And also notions of distributing that trust zone via relay concepts and other ideas, and maybe some thoughts for federating trust are a little farther out. So some other thoughts I have that are not really on my radar so much are an improved group key distributor, maybe something that uses good principles from distributed computing to be fault tolerant, and who do you elect and get a new person to take over, that sort of thing. Other types of distributors, maybe for doing the updates to the trust schema online or something, and updating the signing keys and the trust schema over the network, approaches to doing that. I think some of that work might already be happening. Schemas for other communication models. So ours implements a pub/sub API, which is pretty useful for a wide range of applications. But clearly, if you want to do other things like streaming video, you might want something different. And so I certainly encourage people to do that. There might be other signature managers, and this is one of the nice things about our toolkit is that you just have to go in and write a new one and give it a name, and you can use it. I think I found that a lot easier than trying to change the signature through some of the current library stuff. And I think that I wanted to sort of wrap up with the repo it's called a toolkit because that's what it is. These are things that we put together that we found useful. And I'm kind of hoping to make life easier for other people too. If you don't find it useful, then don't use it. And the other part of it is to really make good use of a trust schema, you need a way of integrating it. And, it provides a toolkit that lets you do that. But again, this is a start. This is a scaffolding. I'm focused initially on this, single root of trust. And that's perhaps not everyone's cup of tea.